And her topic is going to be about incorporating sustainability into transportation asset management. Our future depends on it. And let's just briefly introduce the Professor Tighe. And Professor Susan Tighe is a Canada Research Chair in Pavement and Infrastructure Management, and also Norman McLeod, Professor in Sustainable Pavement Engineering, also a founding principal and director of the Center of Pavement and Transportation Technology, and a professor of civil and environmental engineering at the University of Waterloo. She has been a registered professional engineer in the province of Ontario since 1995. She holds a bachelor degree in chemical engineering. I didn't know that. Okay. From Queen's University, and a master and PhD in the civil engineering from the University of Waterloo. With that, please join me in welcoming Tighe to the talk.
Good morning, everyone. I have a cold, so my apologies for my crackly voice a little bit. I hope you can hear me. Can everyone hear me okay? Yeah. All right, that's good. Thank you very much for the introduction. I know both of your professors that have been here for a long, long time. It is a real pleasure. I was here a few years ago for the boot camp. When was that? 2012. So I actually visited campus at that time, and we were teaching boot camp. Okay, so yeah, you heard a little bit of my background. I actually started my career, I graduated, and then I worked 4 years for the DOT in Ontario. And that was a really great experience. I worked, the first 2 years of my career I spent in construction. Thank you so much. That was great. So I was out on site every day, building bridges, building roads, overseeing sewer, construction, all kinds of stuff. So that was an excellent experience. Then I went into a design section, and then I actually went into policy. When I was still working for the DOT, I started my master's part-time, did most of my master's part-time, and then did a PhD. And I spent a fair bit of time overseas. I spent some time at the University of Nottingham in England, University of Canterbury in New Zealand. I just come back from 9 months. I'm actually still on sabbatical from the University of the Sunshine Coast, which is in Australia. So that's been quite an adventure. My husband is also an engineer, so he took a leave, and we have 2 daughters, and they went to school. So that was a real adventure. And I'll talk a little bit about some of the projects that I'm working on. I think you're familiar where Canada is. I hope you're familiar. Now, who's been to Canada? Okay, good, excellent. I was born and raised in Toronto, which is basically here. And where I'm located is 1 hour west of Toronto, in Waterloo. Waterloo is a high-tech hub. So Blackberry was actually a spin-off from the University of Waterloo. Unfortunately, it was doing very well, not so well more recently, but a lot of high tech in there. As I said, I've just come back from 9 months at the University of the Sunshine Coast of Australia, a beautiful place. Kind of an interesting quote, the most wonderful, dangerous place on earth. So there's lots of snakes and spiders, but you don't really see them, okay? They're not, you know, some people say, oh my goodness, I can't believe you were there, but you don't really see them in the wild. If you stay away from them, they stay away from you. So I had also worked, so some people have asked me, why did you go to Australia? Well, I'd also worked my first sabbatical from the university. I actually worked for a contractor in Sydney. And they were doing a lot of public-private partnership work. So I was a senior technical advisor for their group. So that's been a very, very interesting experience. It's certainly one of the interesting things about being an engineer is you do get exposed to a lot of projects and a lot of opportunities to travel. So this is snow, folks. So this is a typical Canadian winter. So I know you don't deal with that here, but this is what we deal with. So poses some challenges as drivers, but poses a lot of challenges for us engineers. This was Queensland, so this is flooding. So Queensland, Australia, where we were actually stationed during our sabbatical, has had a lot of flooding. And so this is an example of some of the areas that were severely flooded. Okay, so what I want to talk to you a little bit about today is, I provide a little bit of an introduction about the work that we do. I want to talk a little bit briefly about climate change, and so some of the issues that we're trying to address in our research program relate to that. So warmer winters, more freeze-thaw cycles, more flooding. But the main thrust of my talk today is going to be about sustainability and some of the work that we're doing. As a researcher, a lot of my work is lab and field integrated. So a lot of my research is out in the field. That's me as a young engineer over 20 years ago. This is, so building bridge in the background here, building an interchange. What are we testing here? Hard to see. Can we dim the lights a bit? I don't know if the...
Yeah, that's what I try to figure out in the back again. I'm not sure, can we?
For the students, what are we testing? Concrete, yeah. And what are we doing? Slump, yeah.
Oh, there's, okay.
So that's better. Is that?
No.
Can we flip the? Is it all or nothing? Well, flip the lights, but you can't go to sleep on me. Okay. Yeah. So we're testing concrete. I think. Go back. Is that? Can you see better?
No.
Okay. Thank you. Okay. A lot of test sections. And then this is actually one of my former master's students, Carolina. We were out in northern Canada. This is some of the maintenance equipment they were using on runways. You may or may not be aware, but aircrafts in North America fly over the Arctic Circle. So a lot of aircrafts from Europe, and if you're going from North America to Asia, it's usually shorter, depending on where you are, to fly up and over. And so what's happening right now in Canada is a lot of our northern runways are servicing emergency landings. So someone has a heart attack on the aircraft, or there's some reason they need to land, and those are being serviced at Canadian airports. So we've been doing a lot of work to make sure those airports are safe if larger aircrafts must land. So we have a research center. This is the goals of our research center. I'm a director of that research center, and I actually was a founding principal when it started, and so this is some of the work that we do. We integrate field and lab, so we do a lot of testing in the lab, but then we also move that out to the lab, into the field. Focus on emerging and innovative technologies, we'll talk about them. We have state-of-the-art research infrastructure, which you'll see in a moment. So we're lucky at Waterloo that a lot of the facilities and equipment and tools we have, that's the only place they're located in Canada. So we work on some pretty interesting projects. Increase the talent pool of what we call highly qualified people, so that's you. So obviously we have undergrad students, masters, PhDs, but we also do a lot of professional training. We have a lot of sustained partnerships, so long-term partners that have worked with us for 10 years, 15 years. And then we have a mandate to provide national leadership, so we do a lot of work with the federal government, but also across Canada and then internationally. So again, these are some of the research themes: climate change, sustainability, investment, so preservation and expansion. So this is a lot of the work that we're doing on asset management. So you have one budget. So how do you figure out how to apply those monies to the best of the ability? So to improve your network, and also looking at things like safety and customer requirements. Okay, so I have, this is a video that's been produced by the faculty. So hopefully you can hear it. We'll start. It's a short video.
Sustainable pavement is a really big key research theme for us, and really it's about looking at long life pavement design. So trying to design infrastructure that lasts 30, 40, 50 years. We have the capacity here in the lab to test things that no one else in Canada can test. Probably the most high profile project has been the development of a solar road. We're trying to use the pavement infrastructure to generate energy. Our work here is quite unique because we look at the differences in climate. So we look at freeze-thaw cycling. We have the capacity here with our freezer to really torture test our designs. A lot of people look to our research because we're basically testing it at those extremes. It's really important that we, as a research center, evaluate how constructible is it. Can you actually produce something that's high quality in the field? We have over 100 satellite test sections across Canada. We also have satellite test sections that we've advised on internationally. I would really love for us to build a truly long life sustainable pavement. We would basically eliminate the need to go back and maintain it.
Okay, now I gotta close this. All right, okay, so let's talk a little bit about what that means. Long life sustainable pavement, okay? So we have some pretty major issues in the transportation sector. So we have increased cost of materials and construction. There's inadequate funding. I have never met a public sector agency that's had more money than they knew what to do with. Okay, so there's a real challenge of how we make the most of that. We also have the issue of privatization. A lot of agencies have now privatized a lot of their work. So that really changes the dynamic. Green roads or sustainable infrastructure. More reliable design techniques. So I know many of you have heard about some of the new design tools, the Mechanistic Empirical Pavement Design Guide. You know, why are we using some of these new design tools? Well, because we need more reliable design. Asset management, again, we need to be thinking about how we apply our funding and how we apply different techniques to get the highest value. And then there's a lot of other considerations, social considerations, technical, economic, political, and of course, sustainable. So there's a lot of opportunities, okay? So that's the point of the discussion this morning. One of the key target areas is looking at improved recycling. So when we build infrastructure, whether that's a bridge, a pavement, a runway, an airport terminal, this building, we want to try and build it so that it lasts a long time. Okay, because by definition, if it lasts a long time, that resource is committed to that particular purpose. So what we want to try and do is learn from the past, be proactive on climate change. So again, I showed you some pictures, I'll show a few more. We want to design to mitigate natural disasters. So one of the big challenges for us as civil engineers is if, God forbid, there is an earthquake, or there's a volcano erupts, or there is a hurricane. How do we very quickly get that community up and running? Okay, civil engineers play an important role in that process. Leverage the technically savvy next generation, so that's you guys. You know, you don't even remember a time, I heard yesterday, before flat screens on computers. Okay, it's just assumed you all have phones. Okay, there's others of us in the room that actually remember a time when not everybody did have a cell phone. Okay, designing and building smart infrastructure, making the most of the challenge, and then really adopting new and improved design methods. Okay, so again, some of the work that we've done in Canada, because we know that if we continue to design infrastructure based on our historical data, So when I was a young engineer working for the DOT in the design office, we used to take the environmental data that we had for the previous 10 years, and we would use that to design bridges, all our water infrastructure, stormwater, and our pavement. Okay, what we now know is that we can't do that because we've got situations of flooding. So that's actually in Manitoba, another province, where there were flood and that there was a very bad flooded area where they were sandbagging prior to some inclement weather. So we've done some work trying to predict failures. We've done some work where we're looking at premature failures, and those are, I'm saying pavement, but also bridge failures. So if you have structures and your river rises and it continues to be at an elevated height, that has impact on your piers, okay? We're looking at changes over the next several decades, and increases conservatively are 2 degrees to 5 degrees, which may not seem like a lot on the surface, but actually, when you look at your extremes, it actually does have an impact. And in some areas higher. We're seeing precipitation increase up to 10%. There are a few areas where it's closer to 25%. What we're also seeing is that in some areas, the actual overall annual amount of precipitation is the same. What is different is the intensity and duration. So instead of having, let's say, 100 millimeters of rain fall over, 48 hours or 36 hours, we're now getting that same amount of rain falling within 24 hours. Okay? Why is that a problem? So our design infrastructure is for that amount for a 48-hour period, but now it falls within 24. What are we going to get? What are we going to get? Flooding, right. Our infrastructure isn't able to handle that. So there are many vulnerable areas in Canada, and we've been doing a lot of work in that. And then more recently, when I was in Australia, doing the same thing in Queensland, where I was stationed. And again, I'm not going to spend a lot of time on this, but the type of work that's going on is our baseline is using our historical data. These are 2 globally accepted climate change models. And basically what we have here on the x-axis is different cities across Canada. And on the y-axis, this is just one parameter where we're looking at mean freeze seasonal length. So how long is the infrastructure frozen? Okay, and the point I want to make is that it's changing. And generally speaking, what are we seeing here? Shorter. So we're seeing shorter freeze periods. So why is that an issue? Well, in northern Canada, a lot of the infrastructure is in what is known as a permafrost state. Okay, and when you have very poor soil conditions, you want it to be frozen because it's more durable. Okay, and we're looking at precipitation, we're looking at elevated temperatures. So here's a photo. This is a wallaby, so it's a type of kangaroo, where it was stranded due to some flooding. This was just right beside, adjacent to a road. The lower picture, I've also been doing a lot of work in Chile. I'm on an advisory board for the country where, obviously this is after an earthquake. And again, how do you get that infrastructure, up and running very quickly? Because at the end of the day, you need to be providing an important role to get people to safety, to get the infrastructure up and running. So the role of engineers and scientists is really important because we're working to look at better construction techniques, okay, so earthquake resistant. Of course, in this country, where's a major fault? San Andreas, California. Okay, so, looking at design, if you want to be a PE in California, you need to have some seismic. Okay, you need to know something about earthquake design. safety systems, preventing damage, warning, so trying to warn people that there's a disaster coming, monitoring and preventing damage, and then developing plans for emergencies. So, you know, the group that I'm working with is, okay, if the airports are blown out, what do we do? How do we get them up and running quickly? Okay, so that's sort of some peripheral, I mean, I could speak about that work, you know, for the next duration, but I'm actually going to talk more specifically about our work in sustainability. But happy to answer questions at the end. So these are some of the issues we're facing in construction. Shortages of aggregate, which is really important because what percentage of concrete is aggregate? About 80%, right? Okay, what percentage of asphalt is aggregate?
75.
Yeah, 75, even higher, 95% in some cases where you have 5%, depending on volumetrics, but so a big part. So there's an increased cost of production, increased percentage of RAP. So we say green, and the idea is, can we make them more higher recycled content? And then how do we ultimately quantify that? So again, these are the key factors that I'm going to talk about and hone in on how we are actually using some of these different aspects to improve the sustainability. So our research center, CPAT, actually, there's a lot of elements that we look after in terms of sustainable transportation. Obviously, things like traffic planning, public transit. Excuse me, there's a lot of work now going on in Canadian cities about installation of LRTs and sort of different ways of trying to get the public to use transit. How we actually design the road geometrically will impact your sustainability. Land use and development, so there's people that I work with that look at, you know, trying to have nice places to live that are close to the central business district.